All right, so this is problem 16 in chapter 26, and basically we have origin of car versus student and staff. So this is 164, by the way. So basically we're asked if there's a difference in the distribution. Okay. So we got to do a chi-square test here. So we're going to do, if we're looking for a difference in the distribution, we're going to do a chi-square test for homogeneity. So let's go through that. Our parameter here is the distribution of origin of car across students and staff at a local university. Okay. The hypothesis, the null hypothesis, is the distribution of origin of car is the same for students and staff. And obviously the alternative hypothesis is the distribution of origin of car is not the same or different. Okay? The assumptions. This is counted data. Okay, cars were surveyed randomly. And then we got to do the ECF condition. Now, how you do the ECF condition is, for instance, for students, I would do the number of students divided by the total times the total number of American cars to get the American one. So I'm just going to do a couple of these. So there's 195 students divided by 359 total people. Okay, so that's the proportion of students there are, and there's 212 American cars. So I get 115.15. Now the expected can be a decimal. The observed cannot. Okay? So let's do the staff American cars. So there's 105. Sorry, no, there's not. There's 164 staff divided by 359 total people times 212 American cars. And we would get 96.85 expected American cars for staff. And you would do that for all of these. So I'm not going to do them all, but for European, you should get 24.43 or 24.44 for students, and then for students for Asian you should get 55.40, and then for staff for European you would do 164 divided by 359 times 45, and you get 20.56. And then for Asian you would do 164 divided by 359 times 102, and you would get 46.60. So all ECFs are at least 5. So we're good there. Okay? Name the test. This is going to be a chi-squared test for homogeneity. Okay. Test statistics and parameters. Well, we already have the observed and the expected. So we got to get degrees of freedom. So degrees of freedom equals rows minus 1 times columns minus 1. So the rows, we have 3 rows, so 3 minus 1 is 2. And we have 2 columns, so 2 minus 1 is 1. So we have 2 degrees of freedom. Okay. We already have the ECFs up top, so those are done. Obtain P. So chi-squared equals observed, the sum of observed minus expected quantity squared over expected. So we're just going to show our work on here. So for American students, we have 107 observed minus 115.15 expected. Quantity squared divided by 115.15. Plus, we're going to add all the way up to this one right here, the Asian staff. So we're going to add up all these. But we're just showing that we are adding them all up. So we had 47 observed minus 46.60 expected over 46.60. Okay. At this point, we're going to go to our calculator. Okay. Go to matrix, edit, matrix A. Matrix A is 3 rows by 2 columns. And we're going to put in the observed. So you got 107. This is the student row. And then this is the staff row. Staff column, I'm sorry. So there you go. You put those in. Go to stat test, chi-squared test. We have the observed in A. We're going to put the expected in B. And I'm going to draw that up. So that's what that looks like. That goes on your paper. So chi-squared is 7.83. So I would probably put that here. And I would copy this guy on my paper. So chi-squared is 7.83, and the big p-value is 0.02. Now the nice thing we can do here is we can go into matrix and go to matrix B now, and we just push enter, and look, it did all of our expected. So if I bring this down, my students expected should be 115.15 for American, 24.44 for European, and 55.40 for Asian. And then for my staff, I should have 96.85 right there for American, 20.56 for European, and 46.60 for Asian. So we're good to go. Okay. So make my decision. We're going to reject H of O at the 0.05 level. And then my conclusion, whenever I reject the null, is I'm going to go back up here and see what happened. Well, it looks to me like students are driving less American cars than expected and more European cars than expected. So the distribution, actually, I'm going to put, let me try this. There is evidence that the distribution of origin is not the same. Okay, at this university. Now, when I reject the null, I'm going to go and talk about it. So I'm going to go back up here, and here's what we're going to do. We're going to say, okay, here's the deal. It appears that students drive less American and more European cars than expected. The Asians are right about where they should have been, right? For both of them, for both student and staff. And staff, now let's look at the staff. The staff drives more, they have more American than expected, and they have less European than we would expect. And staff drive more American and less European. So it's exactly the opposite, right? Cars than expected. So that's where our differences were. So we've answered the question and we've shown where those differences are.